Welcome, everybody, to our first edition of the Pigment 101 webinar series in 2026. Happy to have you. I'm glad you could join us for this session. Today, we're going to be talking about anti-corrosive pigments, we will, as usual, we will record this session for all of those in attendance. You'll get a link to the recording as well as the PDF of the presentation. And if you have any questions along the way, feel free to put them in the chat box and I'll address them at the end of the session. So with that, I'll go ahead and get started. So I thought it a little bit helpful today to give you an idea of what we'll be talking about today. I'm going to go off camera here. There we go. To be able to, you'll learn, what anti-corrosive pigments are and why they matter. As the name implies, they do provide that corrosion resistance in there. But there's many different chemistries. So we'll take a look at the different types of chemistries and how they work. I'll also give you a little bit of insight into how to select the right pigment based on the performance required and the overall cost of the formulation, not only in that anti-corrosive formulation, but the overall formulation for the end product. And then also some key questions that you should ask suppliers like Sudarshan about the products and your application area. This is important because corrosion costs industries billions of dollars in there. So a very smart pigment selection can reduce failures, warranty claims, and of course the entire life cycle cost of the end piece. So as far as what is corrosion, corrosion is is a electrochemical process that degrades the metal, and this is due to moisture, oxygen, and salts getting onto the actual metal surface to start that corrosion process. Typically, it's steel, galvanized steel, aluminum, and zinc are the substrates and metals that are most affected by corrosion. So importantly for the procurement perspective, that obviously corrosion failures equal repainting, downtime, and of course those warranties in there. From the technical team, corrosion starts. The corrosion process, I should say, starts at any kind of coating defect, thinner edges, and any type of pore that might be in the finish, the top coat part of the finish, that can allow for that moisture to get into the substrate. So the formation of rust, it's part of the category of redox reaction. I'm not going to go into the technical details in here, but it's really important to understand that, as I mentioned in the previous slide, that there is, wherever there might be a divot or a pore or some sort of defect in the top coat finishing, where the moisture and salts can get to the metal substrate, that is where the corrosion will start in there. So it is an electrochemical driven process in here. So all of these things need to be in play with respect to developing rust. And thus the anti-corrosive category of pigments is there to eliminate or minimize the amount of rust formation that you'll get. So what do the anti-corrosive pigments do? They are there to protect the metal substrate. And there's several ways of doing that. They are there to prevent moisture from reaching the metal. They also are there to passivate the metal surface so that they don't accept the moisture. And they could act as a sacrificial protection so that if moisture does pass through that top coat, it sees that sacrificial anti-corrosive layer, and that's where the, the motion stops of the of the moisture. So it's always important to note that the anti-corrosive pigments don't replace a good overall formulation or application. These are there to enhance the full system durability, not just the one layer. So I mentioned the three mechanisms for anti-corrosives, a little bit more about that as far as a barrier protection. This is there to really just slow the water inflow into the system. If it does find a pinhole or a crack, to be able to get through that top layer in there. So typically, zinc phosphates might be used in this type of system to be able to make a very circuitous pathway of that water through that layer and to the metal substrate. The second is passivation. And here the anti-corrosive pigments will react and help perform or help form a protective layer on that metal surface so that the electrochemical activity gets reduced in there. So these are typically phosphate-based pigments. And lastly, I mentioned the sacrificial protection. So in these particular cases, the pigment itself will corrode versus the substrate. So it's that first line of defense, if you will, to that metal substrate that takes the hit to be able to do that. So in this case, zinc-rich pigments are typically used in this type of example or mechanism. So a little bit more on that. I'm a very visual person, so it gives you an idea of what this actually means from the layering perspective. So on the sacrificial one, we have these zinc-rich anti-corrosives that form that barrier so that any moisture will see these and make the reaction versus getting all the way through to the metal surface. The barrier, as I mentioned, we wanted to create the most circuitous path possible from the top layer to the metal surface. So these very large and platelet style pigments will create this circuitous path to get there versus typical pigments that might be more in this spherical type shape in there that is a quicker way to the metal surface. And then the active pigments are there as well to inhibit that that corrosion. So there are a number of types of anti-corrosive pigments. So I just pulled out the most generic types in there. Also give you a view of what type of mechanism they will provide and where they typically are used. So for example, I mentioned zinc phosphates. They both provide both passivation and a barrier mechanism to the formulation. And we see those in all kinds of general industrial type application areas. Modified phosphates, they enhance passivation. So we typically see those in high performance systems. Zinc dust, that acts as a sacrificial barrier. And these tend to show up in zinc-rich primers. Ferrites also act as a passivation and barrier mechanism. These might be something of interest for more eco-friendly systems. And then micaceous iron oxides. These act as a barrier. These are typically seen in heavy-duty coatings in there. So it's from both the procurement and the technical side, in each of these categories, there's a lot of products within these. Similarly, in organic and inorganic pigments, there's a lot of products within a color index. So the performance will vary within that same category. So it's important to match up what your performance attributes need to be for selecting the correct pigment. Regulatory and sustainability landscape. This obviously keeps changing over and over again, and it's always important to make sure that you are uh, up to date and where your products that you're using today fit in. So chromates and lead pigments, they're being banned and restricted, so they're starting to disappear. There's always going to be increasing pressure from the regulatory organizations around the world. And also, there's going to be some OEM sustainability goals to try to achieve via formulation and pigment selection. And that does include antioxidant, anti-corrosive pigments. So in today's world, we're looking for heavy metal free types of anti-corrosives, those that have a low environmental impact. And we're still going to be looking for comparable or superior performance to those older usage type of pigments. Sometimes that's a little hard to do, but that's what our goal is in developing these new pigments. So a takeaway from this is, something you probably already heard before, that compliance today avoids reformulation tomorrow. So looking ahead in your little crystal ball, I'm here to help you make sure that you formulate in the way that you need to do to be able to take you into the next phase of the environmental landscape. So a little bit about how these are evaluated. Accelerated weathering is certainly one of the aspects that we do. So some metrics to consider when selecting products. So as far as on the technical side, there are a number of different test methods that are used, salt spray being one of the big ones, cyclic corrosion testing, adhesion after that exposure, blistering, and is always a big thing to take a look at. From the procurement side, it certainly is important to understand consistency from a lot-to-lot type of application here as far as your supplier is concerned. Technical support is always important in this area. Any kind of qualification data that might be available. And then, of course, supply. That's always the key in today's world, is important to be able to do that. From a pigment selection side, the technical teams are going to be considering, how compatible is the anti-corrosive pigment in their binder system of choice. Is it pH sensitive? The PVC-CPVC balance is always a key one, especially with these very heavy, highly loaded pigment formulations. There also has to be synergy with any other filler or extenders that might be in that formulation, because we do not want them to fight against each other in that formulation. And then, of course, what type of application method will be used for this one. So some are, again, there's many different products in each of these categories, and we want to make sure that you have the right product for your application. And you've probably heard me say this more than once, but it's always good to remind everybody that one pigment does not fit all systems. So we need to match up the right product for your system and application. From the procurement side, there's other things to consider beyond the price. How much cost per square meter being protected do you get from the pigment choice? How much is it going to impact on coating thickness? Can you get away with a thinner film and still get the properties, or do you need a thicker film? That's obviously a cost in use calculation. And then, of course, from the actual performance, does it reduce repaint cycles and field failures? So, of course, those of you who are readily using anti-corrosive type pigments, you're very familiar with these types of test methods in there. So typically the accelerated testing, salt spray and humidity are done to be able to, so quote unquote, speed up the process. And Certainly outdoor weathering is done, but not, sometimes we can't always wait for that time. Analytical data is always important because you need to know a little bit more details about the actual pigment so that you can dial those particular facts into your formulation, especially when there's other fillers and additives in the formulation that we want to make sure that we're not interfering with and causing a formulation failure. So we typically make sure that we have as well-rounded of an evaluation for our products as possible. So we do take a look at all the various types of substrates available for our evaluation, and that includes cold rolled steel, sandblasted steel, galvanized aluminum, and then coil coating type of panels. Again, really trying to understand the gamut of substrates that would be affected by corrosion that we need to evaluate with. We take a look at both spraying and a thicker film via a doctor blade to mimic what might happen in a coil coating process. And then we go through the various scenarios for drying and running the testing. Oops. There we go. So this is a little something of what we are looking for. You're probably familiar with this. So we've got the before with a couple of marks that are put on the film before it is put into the various chambers for the corrosion testing. Usually there is a scribe down the middle. It's kind of hard to see in this slide here, but there is an adhesion crosscut as well on the top coat area. And all of these are done, especially the scribe is done all the way to the metal surface so that we get through all of the layers that are on there so we can assess how much is corrosion is seen after the test. And I did mention about blistering. So these are examples of some blistering that might happen with moisture getting underneath the top coat in there. So as far as the evaluation, the other things that are key to a good evaluation is to know the resin type that it's going into. I did mention the PVC and the CPVC values. These are very high loaded formulations, and it's good to understand where that bit is. What type of anti-corrosive pigment is being used and evaluated, and all of its properties. And also, it may not be a single one. It may be a complementary of more than one. It could be up to three, and I have some examples of that in the presentation. So it's good to understand all of the above to be able to see how it evaluates. Pigment loading, other fillers, pH. So it's really understanding the entire formulation that we're working with, as well as the dispersing conditions that are used for that particular formulation. These are key in combination with the selection of the anti-corrosive pigment. Some common myths and misconceptions. Certainly, a higher zinc does not always result in a better corrosion resistance in here. One pigment does not work for all metals, as I stated before. And the anti-corrosive pigment layer formulation, it may be well on itself, good, but if it's got a poor formulation overall, it may not be helpful. And also the full combination of the undercoat and the top coat in conjunction with each other is important as well. So it's the overall system formulation that needs to be optimized. And then, of course, as we all know, the cheapest option may save money may save money um, in the long may not save money in the long term. So as I mentioned, it's a balanced system approach to be able to provide you um, with your final answer and your best options in here. And you've seen this, you've heard this before. It's really a balancing act to prioritize your wants and your nice to haves in your formulation needs, so that we can help you understand your priorities as well as fit the best options to your priority list. So the Sudarshan portfolio, it's quite broad. We have a number of anti-corrosive pigments in the portfolio that cover almost all the mechanisms that are used for anti-corrosives. So stannous phosphates, modified orthophosphates, polyphosphates, wide spectrum anti-corrosives, ion exchanger here as well, organic corrosion inhibitors, and then flash rust inhibitors. So all aspects of the corrosion process are achieved with the Sudarshan portfolio. It's just a matter of selection of a product or multiple products to be able to get you the performance that you're looking for. So a little bit about each of these groupings of pigments. So corrosion with zinc and calcium phosphates. These are the first chrome-free anti-corrosives that were developed to be able to remove our industry from the chromates. These are well suited for solvent and water-based resins, and they are very suitable for a wide variety of application areas. There is that zinc-free alternative with the calcium phosphate, and so these are used as that barrier layer. As I mentioned earlier, I'm a very visual person, so I have a lot of these photos that give you an idea of what each of these types of mechanisms and how they can work in this case. So the left-hand side is always going to be the control without any undercoat or anti-corrosive pigment. In this case, the middle one is the zinc phosphate in here. So we see some improvement in the scribe area as well as in the crosshatch area, a little bit of improvement there. Certainly an improvement from the blistering perspective. And then lastly, these were developed to replace the chromates. As I mentioned earlier in the discussion here, we're always aiming to be as good as or better in here. In this particular case, chromates are extremely good at what they do. So the zinc phosphate alone may not be the be all to end all. So this tells us that zinc phosphate needs a sort of a helping hand or a partner to be able to get these qualities of the original chromate containing anti-corrosive pigments. The modified orthophosphates, this is a grouping of pigments that provide with more of the longer term protection. They are useful for a wide variety of resins as well. Um, they do have a stabilizing effect on the pH, and they are obviously they're non-hazardous metal complexes. They do function as a adhesion promoter in there, so you do get that as well as the anti-corrosive aspects of it. And again, more pictures. So we talked about the control. The zinc phosphate is the one we talked about a little bit earlier. And then the ZPO and ZPA, two different products in that category to show how the improvement over each one of these can be. So high performance polyphosphates, another grouping of pigments that are available. They are one of the more excellent long-term protective behaviors. These are also good for replacing chromates, especially in high performance application areas. And here's some example. So we have the control, again, on the left-hand side. The modified organic phosphate is here, and then the two products as well are here. So we see some very much improved performance in this water-reducible formulation, epoxy formulation. And then the category of wide spectrum anti-corrosives. These are more universal, applicable in both conventional and modern resin systems. These are there for improving the electrical chemical effectiveness in here. So in most cases, these are used in conjunction with another anti-corrosive so that they interact synergistically for an improved performance level. And I have some examples here for you. And then the other, before I get to that, organic inhibitors. These are used if you consider the time frame or time lapse of corrosion. These are there to reduce the early impact of moisture and salts on the film itself. So if you look at this activity versus time chart here, the organic inhibitors are what I say the first out the door as far as providing protection, and then the phosphate pigments are there for that long protection. So here's some examples of what I just talked about here. So the control on the left, the ZC plus by itself starts to see some market improvements in the crosshatch area, probably similar in the scribe area. But once you have that synergistic effect with the ZC plus and the RZ, now you see a market improvement in the cross with no removal, and also in the scribe there is an improvement. Again, the RZ is there to get that early on performance. Modified silica pigments. This is another category of anti-corrosives, and they are there really to provide that passive layer or a barrier. We've called that before. And again, that barrier is really to provide that circuitous path in there. So they also take that um, those they absorb the corrosion stimulators as well in there. So they have their own properties in there. So we do see this reducing blistering and permeability. It does have that pH stabilizing effect as well. And again, some examples. So we have the control on the left. We do have a competitor that right there in the middle, and the Hoykosil CTF is on the right-hand side. So you can see some improvements in the corrosion resistance for these as well. So the crosshatch is very much improved, as well as the scribe. Flash rust inhibitors. This is a category onto itself. And these products are really there to, as the name implies, to eliminate or minimize the amount of quick rust that occurs on the top coat surface. And here, what we're trying to do is keeping the during the drying process, to keeping the moisture from going through the top coat and getting to that to the surface in there. That creates these little rust spots on top of the surface. And in some cases, you might also see this in the can at the welds and maybe even the outside as well, where it appears that rust is developing. And again, so as far as the synergistic effects, this is another example of how this works a little differently, and in combination with other pigments can provide the ultimate in terms of corrosion resistance. So these also come in two different types: nitrate containing and nitrate free. And if we look down to this chart that we've seen before, this flash rust inhibitor does come in even earlier for that flash rust to be able to inhibit that. Then the organic inhibitor comes in next, followed by the long-term phosphate pigment. Just some examples of the two types of that we have with the nitrite containing and the nitrite free. You can see the difference with those additives to the system. So coming to nearing the end here, I really wanted to give you an idea of a few things to think about as far as a checklist is concerned. Is making sure that you get all the test data that we have. Certainly, global regulatory compliance is important. I'm here to help you on the technical service side. So anything that you might need, just let us know. You can check us on the supplier reliability on these things. These are big volume movers for us, so we do have no issues with the supply of these. And then if there's potentially something that might need to be customized, we're always looking for to make sure that we have the products that you need. So if there's something more that's required, let us know, and we'd like to talk to you about it. It's always important to, and I know you all do, is to involve procurement in the early qualification process. So it's always going to be a team effort on these areas. Future trends. As you've seen through the presentation, we tend to show that for the longest and most effective corrosion control, multifunctional pigments are the way to go to be able to do that. You get the corrosion performance, barrier, and a lot of times we now start to see color being added into the undercoats to allow for a better value and use of your top coat. So if you have a good a similar color undercoat, you don't need as much of a film build of your top coat, and you can potentially help with your overall value and use for your system approach. We're always looking to see how we can improve phosphate chemistries. I already talked about the synergistic pigment packages. And then, of course, eco design coatings in here. So from a key takeaway, hopefully you'll see that and understand that the anti-corrosives are critical for performance in the coatings area. And of course, always a balance between chemistry, performance, and cost. Collaboration in all aspects is very important. And then the sustainable solutions are in today's world the industry standard, unlike the chromates of the past. So on our website, if you take a look at the product finder and take a look at the corrosive pigments protection area, you'll see all the products that are available. There you'll also be able to get the TDSs for each of these products. And if there's something not there that you're interested in, or you need some additional information, just please reach out and I'd be happy to help. Also, we have a number of brochures that we can share with you that give a little bit more information on these to be able to help you in your formulation tasks. And at this point, I'd like to entertain any questions that you might have.